which side of the cell your transporters are on. So if you're looking at an apical membrane, and in that case that's the one that's pointing into the lumen, you know, whether it's a proton secreting cell or a bicarb secreting cell, really just means what transporter is on the apical membrane. Because if you're going to transport out a proton, you're going to have to do something with a bicarb. So it's really the same cell. Really what determines whether it's going to secrete a proton or bicarb is what transporters on that apical membrane. So the reactions are the same, the biochemistry is the same, it's just the physiology of where do you stuff the transporter. So it's really, and that's kind of what we saw in the stomach, with the GI tract. In the GI tract, it'd be the top cell where you're dumping a proton one way or another into the stomach, and the bicarb is going back into the blood, and that gives rise to the alkaline tide. So that's I think that does pretty much does that for you. The next one looks at the role of bicarb in buffering urine, and the lumen is the tubule for the urine. And urine, at the beginning of the tubule, you filter in some bicarb. So you're filtering in bicarb. There's a sodium proton transport system, and it's going to pull the proton from the carbonic anhydrase reaction from carbonic acid and dump it into the lumen. That's going to bind with with a bicarb in the lumen. You're going to get carbonic anhydrase to convert it to water and CO2. So you're dumping acid out. One way to get rid of acid is really just to put it out as water. Put that proton onto a hydroxyl group one way or another. In this case, the hydroxyl group is really coming from a bicarb, and you can send. You're not even acidifying the urine; it's going out as neutral. So this is one method. Note that proton is coming from carbonic acid, and ultimately to keep that cell, this proximal tubule cell, from raising its pH to the point that it dies, and that would happen with the bicarb, you're going to pump out the bicarb, and it's an interesting transporter. It pumps out 3 bicarbs with 1 sodium, so it's a symport system with a cation, 1 cation, sodium, and that allows 3 bicarbs to go out. Well, clearly that doesn't add up. If you just do the stoichiometry for that, you can end up with an awful lot of sodium in this system, because the sodium is just going to take 3 bicarbs out, but it requires 1 sodium per proton you transport. So you can end up with more sodium in there. So there's a sodium potassium ATPase that helps maintain the sodium homeostasis in that. And this is kind of the proximal tubule mechanism for reabsorption of bicarb. So this is kind of like the stomach. If you're going to transport out a proton, there's kind of this associated alkaline tide, if you will. And really, it's not having much effect, because if you could draw a line, you take a line from that bicarb and bring it back to the top of the lumen, say part of that's going in. So you're filtering out some of that bicarb. So this is a system that you're going to use, a standard system, when you're maintaining pH and not having a problem with it. There are a bunch of other systems for doing that, but I wasn't going to bother you with the details. I did want to look at 2 systems